Section 6.5, Graphing Linear Inequalities. A linear inequality is an inequality that is made up of a linear function. A solution of a linear inequality is any ordered pair that makes the inequality true. We want to tell whether the ordered pair is a solution to the inequality. In order to tell whether the ordered pair is a solution to the inequality, we have to plug in the values for x and y respectively and see if the inequality remains a true statement. So y is 4, so we'll put 4 here, is less than 2 times negative 2 plus 1. So 2 times negative 2 is negative 4 plus 1. So we have 4 is less than negative 4 plus 1. And then when we simplify, we get 4 is less than negative 3. This is a false statement. Since this is not true, we know that the point negative 2, 4 is not a solution. We're going to do the same thing in these two examples as well. We've got our x and our y, and we're going to plug it in to see if it remains true. So 1 is greater than 3 minus 4. Well, 3 minus 4 is negative 1. So 1 is greater than negative 1, so this is true. So this is a solution. In the next one, we've got x and y, so x is 4, y is 5. We plug it in. We've got 5 is less than 4 plus 1. When we simplify, we get 5 is less than 5. 5 is not less than 5. 5 is equal to 5. So this is a false statement. And since that's a false statement, 4, 5 is not a solution. So here's some key information for when we're going to be graphing inequalities here in a second on the coordinate plane. When we are dealing with the less than or equal to or greater than or equal to symbols, we're going to be drawing a solid line. When we're dealing with the less than or greater than symbols, we're dealing with a dashed line. When you have the greater than or equal to symbols, you're going to generally shade your inequality above the boundary line. When you have a less than or equal to inequality symbol in your equation or your inequality, you're going to shade below your boundary line. Just some things to keep in mind as we graph. All right, so here's 3 easy steps for when you want to graph these. You're going to solve your inequality for y, or put it in slope-intercept form. You're going to graph your boundary line, and then you're going to use a solid line for these two, or a dashed line if you have one of these two symbols. Then you're going to shade the half plane based on which symbol you have. If you can't remember the shortcut for greater than being shade above, less than being shade below, you can always use the test point 0, 0. And you shade where true. All right. Now we're looking at graphing inequalities on the coordinate plane. So the first step here would be to graph our y-intercept, which in this case is negative 3, and then apply our slope, which is 2. So up 2, right 1, up 2, right 1. And you keep doing this until you have enough points to make a nice line. But before you graph the line, you need to look at your symbol. This is the less than or equal to symbol, which means we're going to have a solid line. And based on our shortcuts, we're going to want to shade below the boundary line. So, solid line means we can go ahead and graph a solid line through the points. So we connect our points. There's our line, and then shading below would be down here. And so this region represents the solution to our inequality. So any point drawn from this area will satisfy the inequality statement provided. Next example, we have 3x plus 2y is greater than negative 8. In order to graph this, we first have to get it into slope-intercept form. So we've got to get everything away from y. So we subtract 3x from both sides. You've got 2y is greater than negative 3x minus 8. Divide by 2. You get y is greater than negative 3 over 2x minus 4. So this is what we want to graph. Looking at this particular inequality, we should notice that this symbol tells us we're going to have a dashed line and that we're going to shade above. So let's go ahead and graph this. Put your first point at negative 4, which is your y-intercept, and apply your slope. Down 3, right 2. Now go backwards to get the rest of your points. And so we want a dashed line, so we'll just make a dash. We'll connect the points with dashes. And so this line represents our inequality. And so the last part for us to do is to shade. And we said we're going to shade above. So we're shading this entire region here. This region represents our solution area. In the next example, we have the same thing. 4x minus y plus 2 is less than or equal to 0. We need to put this in slope-intercept form first. So I'll subtract 2 to the other side. And at the same time, I'm going to go ahead and subtract 4x as well. So right now, I have negative y is less than or equal to negative 4x minus 2. To get rid of the negative in front of the y, we divide by negative 1. When we divide by a negative in an inequality, we have to flip our inequality symbol. So now we should be able to look at this and graph it, and we should know from the symbol we're going to be dealing with a solid line, and we're going to shade above because it's the greater than symbol. So we put our first point at 2, our y-intercept, and apply our slope. Up 4, right 1. Then we go backwards to get the rest of the points. Down 4, right 1, or left 1, down 4, left 1. And we connect our points to make our graph. And so the last part of this would be shading where necessary. Well, we're going to shade above. And so that is this region here. Next example, we have y is less than negative 2/3 x plus 1. This is already in slope-intercept form, so we're good to go. This symbol tells us we're dealing with a dashed line, and we're going to be shading below because it's less than. So we start by plotting our y-intercept at 1, apply our slope, down 2, right 3, down 2, right 3. Go the opposite direction, up 2, left 3, up 2, left 3. So we want a dashed line, so we make dashes. And then we're going to shade below. So we shade underneath here. All right, in this next example, we have x is greater than negative 3. Recall that x equals a number is your vertical line equation. So this is going to be a vertical line that's dashed. And so we'll draw our line, our dashed line at x equals negative 3. And then we'll shade where x is greater than negative 3, so that's going to be to the right here. In the next one, we have y is less than or equal to 2. Remember, y equals a number is your horizontal line, so this is horizontal. And it's going to be a solid line. So at 2, we draw a solid line, and y equals 2. And because it's less than, we're going to shade below in this case. In this problem, they're asking us to write the inequality that represents the graph. In order to do that, we have to remember that most of our equations we write are going to be in some form of slope-intercept form. And so in this case is no different. So we're going to find our intercept and our slope, but then we're going to turn it into an inequality. So our intercept in this case is just a positive 1. Our slope, if we count, would be up 3, right 4. So that gives us a slope of 3/4. So let's plug in what we know. We know we have a y, we have a slope of 3/4, x plus 1. But now we have to look at our inequality to determine what kind of inequality symbol goes here. Well, it's dashed, so it's got to be less than or greater than, and they shaded above. Since they shaded above, it's going to be the greater than symbol. And that's our inequality. We're going to do the same thing in this problem. So let's start by finding our intercept and our slope. Our intercept in this case is -3. Our slope is down to right 1, which is -2/1, which is just -2. So if we plug in what we know, y -2x minus 3, and then we figure out what inequality symbol needs to go here. Well, it's a solid line, so that's going to be the equal to piece, and they shaded above the line, so that's going to be greater than or equal to. So this is our inequality statement.